Hi, everyone. Just wanted to take a minute to talk a little bit about the Pythagorean Theorem, its converse, and then some of the inequalities that relate to the converse of the Pythagorean Theorem. So, you've heard of the Pythagorean before. You've probably used it several hundred times at this point. But just to reiterate, all it is it says if you have a right triangle, um, then the two legs squared added together is equal to the third side, the hypotenuse, squared. Right? You've seen it before. A squared plus b squared equals c squared. There's about 12, maybe not 12, that might be excessive, but there's a lot of different proofs that exist. The most common one might be if you kind of draw, the triangle and then you drew the square shapes off of the triangle. You can kind of, one of the other things that you can do is if you have a square and you kind of break it up into different sections, you end up with a squared plus b squared equals c squared. There's a lot of different proofs you can go use. The most interesting one might be from one of the US presidents, James Garfield, interestingly enough. Look it up. It involves a trapezoid, if I remember correctly. But ultimately, in terms of the Pythagorean theorem, it is just a squared plus b squared equals c squared when you have a right triangle. So let's go through this process. We are given the hypotenuse, so c, and either a or b, really doesn't matter. A and b are interchangeable. So let's say a squared plus b squared equals c squared. So I have 5 squared. I'm just going to call it, I usually call the longer one b for some reason, equals root 89 squared. Okay, so b squared, 25 plus b squared equals root 89 squared is just 89. So b squared equals, when I subtract the 25 from that, 64. How lovely. So that would make b equal to 8. Remember, we're using the positive here because it doesn't make sense for us to talk about a negative answer. Let's hope I did math right. Okay, I did. There's always a chance I forgot how to add. Okay, so let's clear the screen. All right, we'll do the next one. So again, a squared plus b squared equals c squared. These two look roughly the same, so I'm just going to call that a, whatever. A squared plus b squared equals c squared. So I have a squared plus 2 root 6 squared equals 7 squared. Now 7 squared is easy. It's just 49. Now you got to deal with this thing. So when you have something like this, you have 2 squared, which is 4. And this is, by the way, this is being multiplied. So 2 times the square root of 6. You square it. That's the same thing as having 2 times the square root of 6 times 2 times the square root of 6, right? So that ends up being 4 because the 2 times 2 is 4. Root 6 times root 6 is just 6. So you get 4 times 6. So you get a squared plus 24 equals 49. So a squared equals 25. So a will equal 5. All right, we'll do one more for good measure. Okay. I don't want to do that one. New problem. Okay, so let's go through this. Let's do this. Shh, you didn't see me intentionally go pick this type. All right, so we'd go through this process. I'll call it b, whatever. So 6 squared plus b squared equals 9 squared. So 36 plus b squared equals 81. B squared equals, what's that? That'd be 51 minus 6 is 45. So b equals the square root of 45. I'm not going to leave it like that because it's asking you at the simplest radical form. So I am going to take this, to break it down, So b is going to be equal to square root of 9, square root of 5. So that is going to be 3 root 5. There we have it. 3 root 5. All right, so you get the idea relating to the Pythagorean theorem. Now, the only issue with the Pythagorean theorem really comes down to, outside of the fact that it really wasn't invented by Pythagoras, or the Pythagoreans at all, is it requires you to have a right triangle, right? That works when you have a right triangle. What if I just gave you a triangle and I said, is this a right triangle? Can you? So it turns out, by the converse of the Pythagorean theorem, if you do a squared plus b squared equals c squared, and it works, all right? So if it works, then it is going to be a right triangle. So even if you didn't know and you did it out and it worked, it would be a right triangle. But now you're probably asking yourself, well, what happens if it doesn't work? What if I do a squared plus b squared, and I have c squared here? Well, there's really only 3 options, right? We have it works, so that is the right triangle. That's fine. That makes sense. That's the converse of the Pythagorean theorem. But the other 2 options are what? Well, we can either have that this number is bigger than c squared, or we could have that it's smaller than c squared. And as it turns out, this property actually kind of, based on what you know about like the triangle inequalities, kind of is giving you hints as to what's happening. So when a squared plus b squared is less than c squared, it ends up being obtuse. Okay, so your largest angle here is going to be bigger than 90. That makes sense, right? You kind of have one side that is way longer, and that's going to end up with like a triangle that's kind of like long and skinny like this, right? That makes sense. This side's going to be definitely longer. Meanwhile, if a squared plus b squared is bigger, it's going to be acute. Okay? So these 2 right here, these are known kind of as the Pythagorean inequalities. Sometimes they're just lumped in as part of the converse. So either, fine. But this kind of makes sense as well, right? Because when you have kind of one of those, I guess, fuller triangles like that, that's acute. So none of the sides look like they're inherently going to be really big when you square them. All right, so let's do some practice with that. So here I have different triangles, and I'm going to go through the process on them. So first of all, we have to figure out what C is. C is the longest side. C is always going to be the longest side. So as long as you have your 3 sides, C is the longest. So that means I would have 8 squared, 14 squared, I don't know what that is. So 8 squared, so that's 64. 14 squared, I don't know why I checked 8 squared, I know what that is. 196, so if I add them together, that's going to end up being 260. Now what's c squared? 15 squared. 15 squared is 225, so 260 is bigger than 225. Because 260 is bigger than 225, this is acute. Okay. Now, on this one, again, the longest is your c, so this is 100 because it is 10 squared. So here I have 9 squared and 5 squared, so 81, 25. So 106, which again, still bigger, so it's acute. All right, 18 is my biggest. Squared. What is 18 squared, everyone? Anybody know? Because I forgot. 324. All right, 17 squared. 9 squared, so we have 81. 17 squared, 289. I add those together, 370. Okay. That'll end up once again with this being acute. Ooh. All right, let's scroll a few down. Okay, so we just did all those. Let's look at this one here. I have 7 squared, 9 squared. What's 7 squared? 49. It's 9 squared, 81. So 81, so that'd be 130. Now I have 12 squared here, so 144. Well, 144 is bigger, so this is obtuse. And that kind of makes sense. Remember from what I was saying in terms of their shape, the kind of skinnier, longer ones end up being kind of more obtuse as opposed to the kind of fuller ones, like those ones up there. Now, let's take a quick look at this one. So if I have 6 squared, 36. 8 squared, 64. So that added together is 100. 10 squared is 100. They are equal, so this is right. So that's the process you're going to go through every single time to try and determine what each thing ends up being. And if you wanted to check this one, you can tell it's pretty close to equilateral, so you would probably imagine this would be acute, but let's just confirm it. By the way, if they're equal, you pretty much already know it's not going to be right. So 13 squared is 169. So I have 13 squared, 169. 12 squared, which is 144. So 144 plus 169, 313. That is significantly bigger. All right, so that is a cube. Okay. So as you can see, that is ultimately how you deal with the Pythagorean inequality and deal with the Pythagorean theorem in general. So let me know if you have any questions, and have a great day.